the state of Ohio, the average number of fleas on a single eastern blue jay is 300, with a standard deviation of 14. In Akron, Ohio, a flock of 49 blue jays has an average of 314 fleas. Is this flock less or more flea infested than the other flocks in Ohio? All right, so the question is, what's the population here? So you don't need your iClicker. I'm asking more questions than what's on the screen. What's your population? So sorry, I heard just someone raise their hand. Yeah.
Fleas on a blue jay in the state of Ohio.
Right, fleas on a blue jay in the state of Ohio. What is your sample?
Fleas on a blue jay.
Right, the Akron, Ohio sample of 49 is your sample population. So the question is, what is the null hypothesis here? All right, so let's see if this works. So I started it. So enter your answer. It looks like it's working. All right, so most people picked A. And yeah, the answer is A, no difference. So what is B called? The alternative hypothesis, right? Okay, so here's the next question for you. What is the standard error? Will your partners tell you when you are reading this? When I started this survey, they'll let you know if you're So most of you selected C, and there's still some people selected. So how do you find the standard error? So for this, the standard error is 2 for this. Does that make sense, everyone? That's straightforward. Okay, so the next one. What is the z-score? So now please calculate the z-score using the formula. So you have the bottom of the z-score with the standard error. Okay, so it looks like most everyone got the correct answer for this one. One point I want to make is with many of these test statistics, the larger that test statistic, the more likely you are to reject that null hypothesis. So 7 is actually a really big z-score. And if you look at the tables, we're not having you do that, but if you do look at a table, generally if you're around 1.4, 1.5, that's when it gets near that 0.05 p-value. So when you get a really large z-score like this, it's almost always going to, I think I just gave you the answer, reject the null hypothesis. But it's an important point is you can always, oftentimes you can eyeball it, even though you should use the tables. But if you get really big test statistics, then you have a very strong difference among those groups that you're looking at. Okay, so the correct answer for that is 7, and that's how you do it if you were unsure of that. Okay, I'm not going to have you do iClicker for this because I gave you the answer to this. So if the p-value for this is minus 5 to the negative 10 to the negative 8, that's a lot of zeros in front of that. So that's way less than 0.05. Do you reject or accept the null hypothesis? Right, you reject the null hypothesis. So generally that 0.05 is the cutoff. Yeah?
Then why in the first question were we saying there's no difference in the fleas?
So that's the null hypothesis, is there's no difference in the two populations.
But I thought we were just projecting that. Or what was the question? Was it just what is the null hypothesis?
Let me go back. Yeah, what is the null hypothesis? Okay, here's the second question. Okay, and this is definitely more local. In Santa Barbara kelp forest, the average number of intestinal parasites in a kelp rockfish, type of fish, of course, is 45 with a standard deviation of 20. So at Anacapa Island, one of the Channel Islands out there, a sample of 200 kelp rockfish had an average of 30 intestinal parasites. So the question is, are Anacapa rockfish more or less wormy than Santa Barbara rockfish? So what is the null hypothesis here? So I'll let you click in for that. So you notice this one is worded a little differently, but it's still the same point that you're making here. All right, good. So most folks picked A. So the null hypothesis is intestinal parasites are similar between locations. Does that make sense to everyone? Okay, so your alternate hypothesis is then that there is a difference in the number of parasites. You could get a more specific hypothesis, alternate hypothesis, saying there's more there. If you have information, for example, you know that the parasite load there tends to be higher in general. Your alternative hypothesis could be that rockfish populations will have higher parasite loads. But for this, we're saying there's either a difference or there's no difference. Okay, so next question. Okay, what is the standard error for this question?
C or B. I'm gonna say. Yeah. I just don't know how to do this one.
Okay, so it looks like most people chose B. Okay, and the answer is B for that one. Okay, next question. What is the z-score for this one? So calculate that, please.
Because you take the sample minus the population divided by the sample.
So it looks like most of you selected D. Okay, so the correct answer is D. And it shows you how to do it there. And of course, the next question I'm going to ask you. So was that a small or a large z-score? That was large. That was a really large. That was 10. Even if it's negative, it's the same thing essentially. Because that normal curve, it's symmetrical. So this side mirrors this side. And that's an important point with the negative. All the negative does is tell you which side of that normal curve you're on. So 10 is definitely a large z-score. So for this one, wait a minute, I have to clear this. So our p-value is 0.001. Do we reject or accept the null hypothesis? So almost everyone, most people say you reject the null hypothesis. Yes. You reject the null hypothesis. Is anyone unclear on that? Guys, can I have your attention? Is anyone unclear on that, why we rejected it? So in this case, using these data, we would have to say that the Anacapa rockfish have fewer intestinal parasites. Another important point to make too, what's the difference between data and datum? Oftentimes misused. And please, as students, make sure you use these correctly. You'll impress your future research professors or labs you're working in. What's the difference between datum and data? Yeah.
Data is plural and datum refers to one single population.
Exactly. Data are plural. If you're talking about one data point, when you hear someone talking about the data, when they're talking about one point, that's incorrect. So data are plural. So make sure you use that correctly. Okay, so in summary, null hypothesis is generally that there's no difference among groups or between groups. that you're looking at. A high test statistic generally gives you a low p-value and you reject the null hypothesis. A low test statistic generally leads to a high p-value and you'd fail to reject the null hypothesis. So you'd retain that null hypothesis. That doesn't mean that there really aren't any differences. What does it mean? So there really might not be differences, but what's another alternative? Raise your hand if you know something. Well, what is that p-value telling you? That it's not significant, but remember we're using a p-value of 0.05. So there's a 5% chance you're making an error. So there really might be a true difference between those groups, you just didn't detect it. How might you be better able to detect true differences between groups, or among groups if you're checking more than two groups? So for example, for the class, we know the average of the population of the heights of everyone in here. I take the heights of two people, and we reject we retain the hypothesis that those two people we measured are not different from the population mean. That may or may not be true. How can we determine more accurately if that's true or not? Yeah. Right, take a larger sample size. So that's the point I'm making is, especially in biology, you take as large a sample size as is feasible. That doesn't mean you have to measure hundreds of people, but you need to measure enough so that your sample is really representative of what the true population is. So oftentimes in biology, especially in my field of ecological science, it's very difficult to measure lots of individuals. There may not be very many for you to do. Oftentimes we have to go to different types of statistics or just make inferences based on what we know. So that's a very important point to make. Measure as many as is feasible with the resources you have, and just understand that the more that you measure, the more accurately you're going to be able to detect really true differences among populations to help you answer those questions that you have. Okay, any questions? Okay, thanks very much.